In lesson 24, we have two topics. We're going to be talking about equations that have fractions in them, they have denominators. And then we're going to do some geometry problems with triangles that overlap each other. So I want to start out, this is actually a review, something that you did quite a bit of last year. If I have these fractions, who can remind me what I can do to clear those fractions and get an easier problem to solve? Okay, the common denominator is how much? 12, and what do I do with 12? I multiply everything by that. When it is something equals something, I can indeed multiply the entire thing by the least common denominator. So I'm multiplying left and right the equal sign, I get something equivalent, and the fractions go away. If it is not something equals something, if it's just one side, you can't get rid of the denominators. You just have to get a common denominator and add them. But in this case, we're going to multiply everything. So first, the 12 over 4 becomes a 3, and I still have that times the original numerator of 2x plus 3. And then I have minus, and the 12 over the 3 becomes a 4 times the original 4 that I had in the numerator of 4/3. And then that equals, and the 12 over the 4 simplifies and is just a 3. Thumbs up if you're with me. Okay, so then you guys go ahead, race me on this one. Distribute, combine your like terms, and see what we come up with. What's our final answer? Akshita, what's our final answer? So, divide both sides by 6, reduce, and we have 5/3. Everybody feel okay about that? Okay, let's do one more of these. And you guys go ahead and copy that down. Copy down what you think you want to multiply by. I don't want you to go farther than that because I want to make sure we talk about one thing that I want to caution you on as you do these. So, Alexander, what are you wanting to multiply everything by? 15? Thumbs up, thumbs down? Is that good to multiply everything by? All right, so let's get that up here. Let's multiply this whole thing by 15. And then the 15 over 3 gives me a 5 times the original numerator, 4x. And then I have a minus. And then the 15 over 5 gives me a 3 times that original numerator, 7 minus 2x, equals the 15 times 2, nothing cancels. So I just have the 30 over there. Now what you need to be careful about, we are subtracting this whole thing. So do not forget that that minus 3 is what gets distributed to both parts here. So I need some help with the next line on this. Austin, you want to tell me what I get for my next line here? Thumbs up? Thumbs down? Is this good? Right, then we're going to combine our x's so that we have, what, 26 x's? And then if I add the 21 on both sides equals 51. Not particularly nice there, but let's divide both sides by 26. And I can't really reduce that. I could make it into a mixed number if I want. I can either say x is 51 over 26, or 1 and 25/26. Anybody with a question on that? Everybody feel comfortable with that? All right, let's do geometry. So if you look at this picture, hold up fingers, how many triangles do you see in that picture? And then I'm seeing two hands going up. So everybody sees a small triangle on the top and the big triangle that includes everything. The trick for these, to make it easier for you guys, will be draw them separately. So the top one's pretty easy, 2, 3, 4. On the bottom one, or the big one, how long is that whole side? Everybody. It is 5. So the 3 plus the 2 is going to give me a 5 right there. For the next side, how long is it? 3 plus x. I don't know what x is, but I have to put those together to get the whole thing. And the bottom side is just y. So I've got to kind of pay attention. What's labeled out? What do we need to add together? What do we not? Do these both share this angle up here? So this angle is the same as, so therefore congruent to that. If these are parallel lines, which they are in these kinds of problems, what about these angles that I just marked in green? Who can tell me why they are congruent? What's our reason on that, Becky? They are corresponding angles. Very good. That's the hard one, I think, for us to remember on our parallel lines. So these two are congruent to each other. So if I have 2 that match up, well, the third one, AA implies AAA, so are these similar triangles? So now we can set up our ratios on that. So if I go, see, in the bottom one I have an X on the right and a Y on the bottom. So I think I'm going to start with the left where I've got a number. So I can set up 2 over 5. Those are the sides that are across from the angle that's not labeled, so they are corresponding sides. That needs to be equal to 4 over what? 4 is across from the red angle with 1 tick mark, and though, what am I going to get? It's going to be over y. And then I can also set that up. My other side is 3. And what does the 3 need to go over, Hendrix? Perfect. The 3 in the top one corresponds to the 3 plus x. They are both across from the green angle with 2 tick marks. So now you guys know what to do. Solve this proportion, and then solve this proportion. So you guys go ahead and work on that for me. So has everybody gotten y? Someone puts y. Everybody agree 10 for y? So y is 10. And then for the other one, we need to be just a little bit careful. The 2 has to be multiplied by the entire 3 plus x, so make sure you distribute it. Addie, you want to tell me what we write down on our next line? So 2x is how much, everybody? 9. Divide both sides by 2. And x is 9/2 or 4.5, whichever way you want to write that. So now that you've finished your whiteboard problems, let's look at number 2 on the new set, just because it is often confusing. I'm not going to go all the way through it, but we're going to talk about the setup. So we have Henry going to the battlefield. So for that first sentence, we have Henry's rate. I'll do my arrow diagram first here. I have Henry going from wherever he starts to the battleground. But then I have case 2. He starts off going, and then he stops for an hour, and then he keeps on going, but it is still the same distance. It's just he stops for an hour on the way. You don't really need to put that little mark in there. I just kind of wanted to help you understand what's going on with that one. So we know that for this, rate times time, I'll start out with distance. We know distance 1 is the same as distance 2, so rate times are the same for both 1 and 2. Then we're going to fill in what we know. So for the first one, for D1, his rate is how much? 4 miles per hour, and he gets there on time, whatever that is. And then when he stops, if he decides he's going to stop somewhere, he has to go at what rate for the whole trip, not just after he stops. So the second rate needs to be 5. So far, so good. Now the part where English is a confusing language. If he stops for an hour, that means he has that extra hour in there that he really is taking. So he now has, the second time around, he now has 1 less hour to ride. He wasted an hour, or he'd say it was an hour well spent, but in terms of just getting there, he used up 1 of his hours by stopping to talk. He still needs to get there on time. He still started at the same time and ended at the same time. Does it make sense to you guys that over here, that means if he spends an hour talking, he has the original amount of time minus 1 to get there on time? And then I can leave this as that original time here. So now, let's think strategy here. I'm going to let you finish that part. And when you finish that part, you're going to have T1. We reread the question. What are you asked to find? And here's what do we need to find. We need to find the distance. Is time distance? So if I know T1, how am I going to get the distance? I know D1 and D2 are the same. But if I figure out T1, what do I do to get that distance? Dennis? Which rate and time? So am I going to take the 5 times whatever I get here? I need to, if I know T1, and I already know that R1 is 4, that's the one where I know both parts to be able to find the distance. So I'm going to do this with R1 T1, or 4 times the T1 that you found, and then we will label our distance in miles. Thumbs up? Makes sense, Rev?